Hello everyone, this is Mr. Underkoffler. Today we're going to be looking at the guided notes called Adding and Subtracting Linear Expressions. Follow along with me as I read this out loud. It says a linear expression is an algebraic expression in which each term is either a constant, now stop right there, constants mean numbers with no variables at all, or the terms can be the product, which means multiplication, of a coefficient and a variable, meaning some number times a variable, where the variable is taken to the power of 1. All right, so what does this really look like? I made you a very simple little table here to compare and contrast. On the left side, we have linear expressions. On the right side, we have non-linear expressions. So 19x plus 30. Here we have a product of a coefficient and a variable. Here we have a constant. This is what we're talking about here for the terms of a linear expression. But over here, the variable is to the power of 2, so that makes it nonlinear. We have to have just a regular variable where we don't see the exponent because that would make it the power of 1. That's what you have to have for it to be a linear expression. Here we have negative 22r. That is a single term linear expression, only one term, and it is a coefficient times a variable. But over here we have negative 22rs. Notice it's a product of two variables, which is not part of what the definition said you could have for a linear expression. All right, now that we got that vocabulary out of the way, let's review another important vocabulary phrase, additive inverse. We more commonly call additive inverse the opposite, where you change the sign of the number. That's what additive inverse means. It's a synonym for the word opposite. So quick review. The additive inverse of 43 is negative 43. The additive inverse of negative 109 is positive 109. Please make sure you're filling in those blanks on your guided notes. Now let's make it a little bit more interesting. Let's apply this idea to algebraic expressions. The additive inverse of a full expression, 10x minus 29, is, well, each part has to change. So the 10x will become negative 10x. The minus 29 will become adding 29. And this will then give us the additive inverse of the original expression. Here, let me do another one with you. The additive inverse of negative 3x plus 44 is, well, we got to make it positive 3x. And instead of adding 44, we'll make it subtracting 44. All right, now that I've done those two with you, hit pause, do the next three blanks on your own, then hit play when you're ready to see how you did. All right, did you already do the next three on your own? If not, you better hit pause. The additive inverse of negative 18x minus 7 is positive 18x, and instead of minus 7, it's going to be plus 7. The additive inverse of negative 57x plus 16, well, we got to make it positive 57x, and then instead of plus 16, it's going to be minus 16. And then finally, the additive inverse of 8/13 x minus 2/11 would be negative 8/13 x plus 2/11. Okay, so why did we just go over that? Well, you guys all know that subtraction is the same as adding the opposite. Now, the word opposite is a synonym for additive inverse. So what we're going to do if we have subtraction between two linear expressions, we are going to make it become adding the additive inverse. Now, let's break this down to the simplicity. Always look at what you have in between. If there's already adding, then you're not going to use this rule because you don't have a subtraction problem in between the parentheses. But if you do have subtraction in between, like on problem number 2, then you're going to have to make the expression to the right of it become its additive inverse, because we're going to make subtraction become adding the additive inverse. Now, before I do number 2 with you, let me talk you through problem number 1. Now, this is already fully typed up for you, but let's break this down piece by piece. On problem number 1, notice we have addition in between. So, do these parentheses matter? Well, over on the right side, I gave you a little key here. When do parentheses matter? If there would be a multiplier sitting outside of the parentheses, like right here, this 3 is multiplying to the parentheses. well, then the parentheses would matter, and you would have to use the distributive property, which we learned about in a previous lesson of guided notes. If there is subtraction to the left of the parentheses, like we saw on problem number 2, then the parentheses to the right of that do matter, and we're going to have to deal with that subtraction and make it become adding the additive inverse. But back on problem number 1, do we have a multiplier sitting outside of the parentheses? No, we do not. Do we have subtraction to the left of this set of parentheses? No, we do not. We have addition in between. So this is why I wrote this little message for you. These parentheses here on problem number 1, they really don't matter because there's no multiplier sitting outside of the parentheses and there's no subtraction in between. It's just addition. So you can really just drop those parentheses and then finish the problem from here. Before you can switch the order and get your like terms next to each other, the x's next to the x's and the constants next to the constants, you're going to have to make the subtraction here become adding the opposite. And yes, you can do that on the original expression. You don't have to make it a separate step here like I did. After you make subtraction adding the opposite and you have addition, addition, and addition, then you can switch the order. That's called using the commutative property and get your like terms together. These like terms here give me 6x because a negative plus a positive, you subtract in your head. And then the constants, they are like terms with each other. Since again it's a positive and a negative, you'll subtract in your head and you'll get 11. And you won't add these together here. You will not make this 17x because as we all know, we will never, ever, ever add unlike terms together. Now, before I move on to problem number 2, I do want to show you an alternate way that you can finish this. When you get to this point here where you have dropped the parentheses and you made subtraction here adding the opposite, what you can do is you can line up the two linear expressions on top of each other, where you take this expression here, write it on top, and then this expression here and write it underneath. Kind of like you were adding a 2-digit or 3-digit number back from elementary school. It's really similar to this. And then the like terms are already kind of lined up on top of each other. Now, if you're like, whatever, I don't need that, I can use commutative property instead, like I did in the other packet of guided notes, then fine. But if you kind of like how this will make the like terms already line up on top of each other, then maybe you want to consider doing this alternate way of finishing your work. The choice is yours. All right, let's take a look at problem number 2. This one, different ball game. Why? Because there is subtraction in between the parentheses. We know subtraction is the same as adding the opposite, but let's use the vocabulary, adding the additive inverse. So what I'm going to do is I'm going to make the subtraction become addition. The first expression stays the same. Remember how whenever we made subtraction become adding the opposite when they were just two numbers, the first number to the left always stayed the same? Well, the first linear expression will always stay the same. But subtraction will become addition, as you see I did here, and then the entire linear expression to the right of it will become its additive inverse. Very similar to what we just practiced here in the middle of the page. So let's do that here for problem number 2. The positive 14x will become negative 14x, and the minus 20 will become adding 20. Just like we practiced in the middle of the page. And then now we can actually take away the parentheses because we now have addition to the left of it instead of subtraction because we made it adding the additive inverse. Now, before I finish this problem, you do always have to look to see if you have subtraction anywhere else, and we do have it right here, so we will have to make that become adding the opposite. And then you can finish number 2 the same way you finished number 1. You have two choices. You can either use the commutative property, get your like terms next to each other, or you can take the first linear expression, write it on top, and the second linear expression, write it underneath, and then your like terms will already be lined up, and you'll go ahead and get your answers. Remember, when you have a negative plus a negative, you'll add in your head. When you have a negative plus a positive, you'll subtract in your head. Okay, Turn the page. If this seems a little sketchy, a little overwhelming, no problem. I'm going to do number 3 and 4 and 5. That's right. I'm going to do 3 problems with you to help you to get the hang of this. Once you do a few of these with me, then you'll see it's really just making subtraction become adding the full additive inverse of the expression to the right of it. And it really won't be that big of a deal. You'll get the hang of this after 3 problems. Okay, problem number 3. First thing we look for is what do we have in between. If it would be addition, then it'd be a problem like number 1, and you would basically just drop the parentheses and take it from there. But if there is subtraction, we're going to make that become adding the additive inverse. So, pencils in your hand. Start this with me. The first expression never changes. But subtraction will become adding, and the very next linear expression will become its additive inverse. So, what's the additive inverse of negative 7x plus 20? It's positive 7x minus 20. Write that down. As you can see, I'm making subtraction become adding the additive inverse of what we had to the right. It's positive 7x and minus 20. If you can get that step right, these problems are not going to be a big deal for you at all. Now, before I go any further, I need to look to see, do I have subtraction anywhere? Nope, here's addition, here's addition. Oh, here it's subtraction, so I will make that become adding the opposite so that now I can either use the commutative property and get my x's next to each other and get my constants next to each other, or if you would rather line them up on top of each other, where you take the first linear expression and you write it on top. Then you take the second linear expression and you write it underneath. You guys decide right now, as you have your pencils in your hand, if you want to do it this way that I have here in these dashed lines, or if you just want to use the commutative property like I wrote right here. Both ways will give you the same answer. Here, I'll prove it to you. The negative 22x and the positive 7x, you'll subtract in your head, you'll get negative 15x. Same thing over here. The positive and the negative constants, you'll subtract in your head. That will give you 10, just like it will here. Both methods work the same way. I do not care which way you finish the problem. Okay, let's do number 4 together. What do we have in between? We have subtraction. So, subtraction needs to be made adding the additive inverse. Will the first expression become its additive inverse? No, the first expression will stay the same. Will the second expression become its additive inverse? Yes, because we're making subtraction, adding the additive inverse. So 19x will become negative 19x. Minus 6 will become adding 6. And now, before I finish this problem, look what we have in between. Here we have plus, here we have plus, here we have minus. Oh, that's where I need to make subtraction, adding the opposite before I am allowed to use the commutative property. Now, if you don't want to use the commutative property, you can line up the 2 expressions on top of each other. But if you would rather use the commutative property, then your next step of work is going to look like this, where you get the x's next to each other, and then you get the constants next to each other, negative 8 and positive 6. All right, let's finish this together. 3 and negative 19x, you will subtract in your head and get negative 16x, no matter which way you're doing it. Negative 8, positive 6, that's going to give you negative 2, no matter which way you're doing it. Oh, wait. Do you remember that thing I taught you on a previous packet of guided notes? That if you have 2 symbols in between a term and another term, that's not considered to be in simplest form. So instead of making this plus negative 2, I'm going to have to make this minus regular 2. Now, I can do that because subtraction of 2 is the same as adding negative 2, adding the opposite, except I'm doing it backwards to make it look simpler, so that way I don't have 2 symbols in between the first term and the second term. If you're like Mr. Underkoffler, why did you not do that on problem number 3? Because it was plus regular 10. I already only had one symbol in between. Here, I had plus negative, which was 2 symbols in between, so I need to make that simpler and make it minus regular 2. All right, problem number 5. Should I make this become adding the additive inverse? Well, look what we got here. It's already addition. So this is the easy kind where nothing's going to change. It's just going to stay the way it is. Drop the parentheses, just like problem number 1. Now, before you finish this, look to see what's in between. Here we have minus, make that adding the opposite. Here we have minus, make that adding the opposite. And then, if you would like to line up the two linear expressions above each other, you may. If you would rather use the commutative property and get the 12x next to the 1x. Oh, do you remember? X without a coefficient next to it is the same as 1 times x. I'm not saying x equals 1. Do not misquote me. I'm saying x where you don't see a coefficient next to it, a number multiplied next to it, is the same as 1 times the x. And then you can say 12x plus 1x is 13x. Now, negative 5 and negative 1, they're like terms. Since they're both the same sign, you will add their absolute values in your head and get negative 6. Oh, we're not done. There's 2 symbols in between. So we're going to simplify this to just 13x minus 6 instead of saying plus negative 6. Okay, now that we have done 3, 4, and 5 together, I think you should be able to do the next 3 problems on your own. So don't go the whole way to the ones with fractions. For now, just do 6, 7, and 8 on your own, and then after you've done, then you'll get to see how you did. So hit pause now, do 6, 7, and 8, then hit play once you're ready to see how you did. All right, did you already do 6, 7, and 8 on your own? If not, you absolutely need to hit pause now. So that way you're doing some practice on your own. All right, here I go. This already had addition in between, so nothing will change. Nothing. Now, before I finish this, I will look to see what I have in between, and here I had minus, so I'll make that adding the opposite. And now I will either line up the like terms like this, or I will use the commutative property. Either way is up to you. The negative 42x and the negative 19x gives you negative 61x, and the negative 39 and 2 will give you negative 37. Since it's plus negative, we will simplify that to minus a positive 37. There you go, negative 61x minus 37. If you messed up, hopefully you're hitting pause and fixing your mistakes as needed. Problem number 7. Notice what's in between. This time we have minus. So we are going to have to make this become adding the additive inverse. Now, the expression to the left does not change, but the expression to the right, that one does become its additive inverse. So this will become negative 5x, and instead of minus 8, it will become plus 8. All right, we have plus, plus, and plus. Oh, cool. I don't even have any minus this time that I have to make adding the opposite like I did over here on problem number 6 right here where I have this in blue. Problem number 7, it's plus, plus, and plus. So I can go ahead and finish this off. Either do the lining up method or do the commutative property. Choice is yours. Negative 2x and negative 5x is negative 7x. And then 11 and 8 is obviously 19. And this time, it's just plus regular 19, so there's no simplifying you have to do at the end like we did on problem number 6. Problem number 8. What do we have in between? Oh, we have subtraction. So we're going to have to make this become adding the additive inverse. But the expression on the left will stay the same. The expression on the right will become its additive inverse. Instead of negative 4x, it's going to become positive 4x. Instead of minus 3, it's going to become adding 3. Now this time we do have minus here, so we're going to make that adding the opposite before we continue. And now we will line up either our expressions off to the side like here, or you will use the commutative property and get those like terms next to each other. 11x and 4x is 15x. Negative 32 and 3, negative, positive, subtract in your head. That's going to give you negative 29. Oh, but do you see what I see? Here we have two symbols in between, so we need to simplify this. The plus negative we will rewrite as as subtracting a positive. All right, now that we went over those, how about I do number 9 for you? I know it looks a little scary, but I promise you it's not meant to be scary. I'll do 9, then you will try 10 on your own. So here we go, pencils ready. What do we have in between? Oh, we got minus. So we are going to have to make this become adding the additive inverse. But before I do that, the expression on the left will stay the same. The expression on the right, it's got to become its additive inverse. So it's going to be negative 2/5 x, and instead of plus 1/6, it's going to become minus 1/6. Now, before we go any further, since there's minus here, make that adding the opposite. And then let's either line them up off to the side, if you like that way of doing it, or we will use the commutative property and get the terms with x's next to each other because they're like terms, and then the constants, the numbers, the fractions that had no variables at all, they're like terms. Now, if we were not allowed to use a calculator, you would need to do a lot more work here. You would have to get common denominators since you're adding. But since you're allowed to use a calculator, in your calculator, you can just go ahead and enter in the fractions. There is no variable key that you hit. Just type in the coefficients here. We got 4/15 and negative 2/5. Enter that into your calculator, obviously with plus in between. And that should give you negative 2/15. Keep the x. Now, what about 2/3 plus negative 1/6? Do that in your calculator. And that should give you 1/2. And since it's plus positive 1/2, there is nothing you have to simplify at the end. All right, so really not that big of a deal since you have a fraction key on your calculator that you're allowed to use. Hit pause, do number 10 on your own, and then hit play when you're ready to see how you did. All right, did you already do number 10? Here we go. There is subtraction in between, so we're going to have to make this become adding the additive inverse. But the expression on the left will not change. The one on the right is the one that becomes its additive inverse. So instead of negative 3/8 x, it's going to be positive 3/8 x. Instead of plus 11/12, it's going to become minus 11/12. Since there's minus right here, we're going to make this adding the opposite. Since there's minus right here, we're going to make that adding the opposite. From here, you either line them up or you do the commutative property. The x's, when you add them together in your calculator, will give you 27/40 x, and the constants will give you negative 1 and 1/6. Oh, since there's plus negative, we're going to have to make that minus a positive. And there you go. That's problem number 10. And that's going to be the end of this video. The rest of the guided notes, which get into some word problems, I will make that a separate video. So thank you for watching. We'll see you next time.